Okay, so in this video, we're going to take a look at how we can solve certain quadratic equations using square roots, okay? So you can't do this for every single type of problem, but this would be something that we can use it. 4x squared minus 9 equals 0, we can definitely solve this using square roots, okay? Now, for a problem like this, you could also solve by factoring. So remember, you could factor 4x squared minus 9 to 2x minus 3 and 2x plus 3, and then set each of those equal to 0 and solve. And you would get x is equal to plus or minus 3 halves, positive 3 halves and negative 3 halves. Okay, so like for this example, you could solve it by factoring, but that's not always going to be the case. Okay, we can also solve this using square roots. Okay, generally we're able to solve using square roots when we're missing our linear term. Okay, so remember that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. Notice this problem doesn't have the bx term. That's our linear term. This is a dead giveaway that we can solve this using square roots, okay? So there's really just 3 steps to solving using square roots, okay? The first thing you want to do is you want to isolate the squared term. So in this case, x squared is our squared term, so we want to get that completely isolated. So our first step would be to add 9 to each side. So we would add 9 to each side to get 4x squared is equal to positive 9. And then from here we would divide each side by 4 to get x squared is equal to 9 over 4. That's a sloppy 9, but that's a 9, okay? 9 over 4. So that's your first step. You want to isolate the squared term. And now, once you get here, you want to go ahead and take the square root of each side, okay? I'm going to take the square root of each side. And what this is going to become, well, when we square a square root, they cancel each other out. Those are inverses of one another, so this simply becomes x is equal to, and I put a little important piece of information here. Whenever you take the square root of each side, you always need to have plus or minus. So this is plus or minus the square root of 9 over 4, which can be split up into the square root of 9 over the square root of 4, okay? This is the exact same thing as saying the square root of 9 fourths. So you can split it up and make it 2 individual radicals, okay? And that's extremely useful in this case, because if we can simplify here, we should go ahead and do so. And in this case, we would. The square root of 9 is 3, and the square root of 4 is 2. So we get x is equal to plus or minus 3 halves, just like we would have if we had factored, okay? So that is an example of how we can solve using square roots. I want to take a look at just a couple more problems. So for example, let's say we had something like this. Let's say we had 9x squared plus 15 is equal to 0. Now notice how once again the linear term is missing. We don't have a bx term. That's definitely a dead giveaway that we can solve using square roots. So I can subtract 15 from each side. We want to isolate our squared term. So in that case, I'm trying to isolate this x squared. So the first step would be to subtract 15 from each side. So I get 9x squared is equal to negative 15. I still don't have this isolated yet. So 9 is multiplying x squared. So I want to divide each side by 9. So that's going to get me x squared is equal to negative 15 over 9. And I know some of us might be kind of itching to turn this into a decimal. Highly recommend against it, okay? Because we're going to want to get our answers to be exact. And chances are, if we're going to be involving square roots, the only way to keep it exact is to keep it as a fraction, okay? Because whenever you take the square root of a decimal, more times than not, you're left with an answer that's irrational. That's a decimal that's going to continue forever. And I don't know about you, but I don't really feel like wasting the rest of my life writing out all those decimal points. So keep it as a fraction to keep it exact. Okay, little tangent. But now we have x squared completely isolated. So now we can take the square root of each side. And once again, when we square root a square, those cancel out. So we get x is equal to plus or minus the square root of negative 15 over 9. which I can split up into the square root of negative 15 over the square root of 9. And now I can simplify this. This is plus or minus. Look here. We have a negative underneath the square root. Now we're finally getting into where solutions could actually be imaginary. So remember, the square roots. Remember, I is the square root of negative 1. So what I can do is I can pull an I out. So that becomes I times the square root of now positive 15 over the square root of 9, which is 3. Okay, so that's 2 examples that are a dead giveaway. I want to go over one more example. Okay, I want to go over one more example that looks a little bit different. Okay, I want to go over another example that looks just a little bit different. So what if we had something like this? 4 times the quantity of x plus 5 quantity squared minus 49 is equal to 0. Now this problem looks fairly different from these, okay? It looks a little bit different, but you can actually still solve using the square root method, because as you can see, we still basically have a number multiplying out in front. We still have a value adding or subtracting, and instead of having just x squared, now we have a binomial squared. So all that means is that now our squared term is a binomial, but I still want to get that squared term completely isolated. So I still follow the exact same procedure. I would isolate it. So our first step would be to add 49 to each side. We add a 49 to each side, and when we do that, we're going to have 4 times the quantity of x minus 5 squared is equal to 49. But I still don't have my squared term isolated. So now what I have to do is I have to divide each side by 4 to get rid of that 4 here. And now I'm going to get x minus 5 quantity squared is equal to 49 over 4. And here we have the square term completely isolated. So now, just like before, I can take the square root of each side. And once again, if I square root a term that is squared, they cancel out. So that's going to leave us with what was underneath, which is just x minus 5 is equal to plus or minus the square root of 49 over 4, which, as you could see from the previous problems, that's the same thing as the square root of 49 over the square root of 4, which is the square root of 49 is 7, and the square root of 4 is 2. So we get x minus 5 is equal to plus or minus 7 halves. And the only difference with this problem is that we have one extra step. X is still not solved for, so now all I got to do is I have to add 5 to each side. So I get 5 plus or minus 7 halves, okay? And we don't want to leave our final answer. That way we can actually go ahead and find out what that is. You can use your calculator, but you can go ahead and do it by hand. 5 is the same thing as 10 halves. Oops, is the same thing as 10 halves. So now I just have 10 halves plus or minus 7 halves. So well, 10 plus 7 is 17 over 2, and 10 minus 7 is 3 over 2. So those would be our answers, and that is solving using square roots. Okay, that is solving using square roots. So remember, your first step, you need to isolate the squared term just like we did in all of these problems. We need to take the square root of each side. Remember, don't forget the plus or minus, and then we solve for x. So we had a few different cases. We even had an imaginary solution here, or complex conjugate solutions here. We involved our letter I, our imaginary number I, and we even had one that wasn't just x squared, it was a quantity squared. But all of these are problems that you could definitely use the square root method, solve using square roots, okay? Tune into the next video. We're going to be solving using complete in the square, which is actually going to be using these exact concepts. So tune into the next video, complete in the square. Very important concept, okay? Stay tuned and check out that video.